Hello, everybody. I think we should be good. We should be live now. I still need to fix a couple things here, but we're almost ready to go. So sorry about being a little bit late today. I ended up having some traffic problems getting here, or not getting here. Let me think about this. This is a little hard to process in my head, right? So here is my home, but here is also the stream, and thinking about them as slightly different things is kind of confusing. But in any case, I'm here now, we're ready, we are streaming. So, still a little bit of a cough. Hopefully everything works. I still need to update this right here. Here, it's going to be Monday. We're looking at more numpy bugs. That's still true. And this is going to be numpy case or jinky. I think it looks about good. I think it's about everything, right? So I think to recap from Monday, basically spent Monday running around in circles and not making a ton of progress. Not that that's a bad thing, right? Like, we definitely did not get the progress that I would have hoped for, which, of course, was quite disappointing. But we didn't do nothing. So if you missed it, basically what happened on Monday was that we started looking at our crashes. We have a whole bunch of these numpy crashes that we've been working on for a couple weeks now. And so we wanted to then do some triaging them. So we have, where does this window get to? So in crashes Python, we have all these different unique EIP or RIPs that we crashed on. And for the most part, you want to know, okay, we have these. Which of these are useful? Which of these are exploitable? And which of them are unique? And the first step in finding out if they're unique is we just ran some scripts, we pulled them out, we decided to see, oh, here are the unique RIPs. Super simple, nothing complicated at all about doing that. It's a little bit of GDB in Python to parse it. After that, we started looking at them. And in particular, let's see here, I believe it is, so crashes, Python, 7FF, I believe it's the 689 one. I believe this is the one that we were looking at in particular. But we should also have notes here to cover it. Yeah, so it's it's the 781. 786F46 7806. This is the one that we were looking at. And so just to recap what this was. This is what we were looking at. Relatively simple. We apparently use set field on a column stack, and that causes a what looks like an out of bounds write. So when we actually run this, so OX7F 786. Yep, that's caps lock. So we run this. We run. Oh, right. So the other side of what we did was we tried to get an ASAN build running on here because we wanted to know when we got the out of bounds right. And unfortunately, I can't show you why we thought it was an out of bounds right. The short version is the type of abort we got from the malloc asserts indicates that we probably had an out of bounds right on a heap allocation. What we wanted to do was get ASAN built so we could see when that right happens, as opposed to when it eventually crashes when it does the garbage collect at the end of the Python process. Relatively straightforward. The problem is, that's pretty hard. getting Python and asan to build, or Python and numpy to build with asan. I think we spent an hour and a half to 2 hours trying to get that to work, and never actually made any real progress with it. So, there's a few things that I want to do today, and the first of those is, we can get rid of these. We want to do the, I'm going to call it just a basic reset. And then the other thing is the janky asan. And I'll explain that as we get to it. But the short version is, what I'm hoping for here, I don't know if this is going to work or not, is if we have the regular regular numpy. So first off, I want to switch out the Python in the system. So which Python? So the problem here is if we go into Python source, we built this Python, which runs. But if we try to import numpy, we can't get it because we're looking in the wrong directory for it. Okay, that seems unfortunate, but relatively straightforward. And we can't get it set up with virtual env for reasons. So what I want to do here, and this is probably going to completely trash my system, is I want to see what happens if I just drop this thing into the where my current Python is. What happens? Sorry, my cough is still giving me a little bit of problems. It's not too bad, but it's definitely still there. Oh. So, sudo su. I'm going to type in my password now. And I want to just do cp python usr bin python. And there's a decent chance that when I hit enter here, I kill Python, and my solution here is I'm going to have to look up how to reset a package out of apt and just blow away both numpy and Python and get us back to where we should be. Text file busy. What? Oh. Oh. To start with, we're still running Python. Let's fix that real quick. Kill all Python. We still have a screen session here that let me check that real quick. Fortunately, I don't think you're going to be able to see this. I don't have it set up so that you can. 5, 1, 3, 4. I do, in fact, still have a screen session. We're going to kill all that. I apparently never killed it last week, so... Okay. So now, that looks better. Okay. There's a decent chance that I just completely screwed my system and nothing is ever going to work again. Oh, that's exciting. That's super exciting. Yeah, I've broken everything. It's awful and will be awful forever now. Because now, we're apparently crashing because I didn't copy the libraries into yeah. Okay, so we want to do a apt get upgrade. I guess works. Are you going to replace Python? You're not replacing my Python. I want to do it. That seems like a really interesting crash. So the crash I'm getting there is not interesting at all because it's because I replaced the Python binary and not the libraries, and it's just me being dumb. I want to do a apt get. How do I do that? What does Google tell me? Apt get reinstall. Oh, I do -- reinstall. Okay. Install Python reinstall. So I'm doing here, right, is I'm going through and I am resetting Python back to what ships with this version of Ubuntu. So hopefully, when I run Python, it should just work. Why didn't you just work? Oh yeah, the fuzzing one is hopefully interesting, given that it's on a set, like this set field function is what's causing a crash. Super hopeful that it's something useful. Well, that didn't quite work. I should be able to apt-get install -- reinstall. -- reinstall. Python numpy. Oh, this is awful. I think I might have just killed everything. Oh, joy. Sudo dpackage -- configure -a. So what I'm hoping for here apt-get remove python - numpy. Just go away. So I'm a little bit concerned about purging Python because I don't want to. Oh, jeez. I have broken everything on this system, haven't I? cd/usr bin ls python. Okay, so the good news is okay. Well, I was going to say the good news is that I just overwrote the symlink there, but apparently CP follows the symlink, and so that is not actually true. Python 2.7 - debug. Does that work? It does work. So, Python 2.7 - debug, Python 2.7. Okay. Okay, so that kind of works now. I'm hoping what the problem here is that apt uses Python on the back end. So Python - numpy. So because I completely broke my Python install there, I'm hoping this works now. And this is why I am not at all a sysadmin. So good news is this looks like it worked, right? So we were getting the ref counts from using Python debug. We are not getting the ref counts anymore. Okay. Why? I'm okay with using this version. It's not, you know, ideal, but I can live with non-ideal things. Crashes, Python, OX7. Okay. Why did we not work? Apt-get remove python-numpy. Go away altogether. So the error we're getting there is because we have the, at least what I suspect is happening is that we have the numpy build with asan, because we got that to build properly. We installed it over, but when we actually use that library, it doesn't work because it's trying to access a symbol that it can't find. At least that's the guess I have. Install python-numpy. Yeah, if this doesn't work, I will go the route of purging and see if that works. iDebug might have import issues. It might. Python import numpy. Okay. So, however, we're still using the version we built on Monday because we're getting those asan problems. So, at least that is at least relatively straightforward. And that is root. Yes. So if this works the way that, you know, computers work in my head, well, that's not how that's supposed to work. I just removed Python numpy. Like, if I do an apt-get remove, pip. Why do you still have numpy? Pip sudo pip uninstall numpy. I want you to go away, numpy. Yes. So now we should be able to come over here, import numpy. No module named that. That is what I want to see. Actually, let's install it with pip. Not sure if it matters if I install it with pip as opposed to apt, but I'm okay with that. We're downloading a new version of it, which is what I want to see. We're installing a new version of it. So hopefully when this finishes, which should be soon, we will hopefully be able to, you know, get something useful out of this. What that useful thing is, we'll see. Well, so once this all works, hopefully it is going to give us did that stop? Okay, it's still running. Yeah, so hopefully what's going to happen here is we're going to get this installed, we'll be able to run it and get the crash. Since what we were trying to do before didn't work, the backup plan here is if we can't get asan to work, we can't get asan to build, we can build our own. And one of the reasons I want to take a look at this is because there's a number of cases where I don't have source. If I don't have source, I can't build something with asan. It just doesn't work. In order to use asan, I have to be able to build it. And if I don't have source, I can't build it. What I can do, though, is I can build something that does roughly the same thing as asan, but not quite. And what we're going to do, if this ever finishes, is we're going to do exactly that. And so the way we're going to do it is we're going to build what I'm calling janky asan, which is basically just going to, we're going to use LD preload to replace the malloc and free on when Python goes to call those. So instead of having malloc and free getting called, we're going to use our malloc and free, which are going to set up they're going to set up a page with it, and so Jafra, when we did the fuzzing, we did it on whatever version shipped with Ubuntu 16.04, which I believe was 1.11. The triaging we've been doing is on 1.12. So the first thing that happened last week, or on Monday, was, as we can see over here in the notes, there were several of these crashes that don't reproduce because of changes they've made between those versions. I'm not sure what those changes are. Hello, Cassiano. I don't know exactly what the changes are between the versions, just that there appear to be new checks in place that are stopping us from doing whatever was causing the crash in the first place. So ideally what we would do now is once we triage all these crashes, depending on where we get with this, I think what we're going to do is we're going to improve the fuzzer a little bit and rerun it on the newer version. But that might be a little ways down the road. Like it might take us quite a while to triage all these, especially at the rate we're going. Like at the current rate we're going, it's going to take us probably 2 or 3 weeks of triaging these crashes. So we may all be bored of numpy by then. We'll see. Why is this not finished yet? Like, this should be relatively quick, right? Something running in the background. What is going on? Sudo kill all -9 cc1. Okay. Install for me. At least, I mean, that's the theory here, right? The theory here is that we should be able to build a replacement for malloc, which basically uses guard pages to do something similar to asan, to be able to identify those out-of-bounds read and writes. I guess numpy is being compiled when I install it. Yeah, I suspect that's what's happening here. So I'm going to give this one more try, and if it doesn't install pretty quickly here, like this doesn't install before I get bored of it, we're just going to install it out of apt instead and use that one. Because, you know, I've already messed up the system plenty. I think switching between pip and apt for Python library management is the worst, is nowhere near the worst of the things that I've done to it. Yeah, I'm getting bored of this. Okay. Sudo apt get install python-numpy. Yeah, I saw that. Thank you very much for taking a look at it. When we come back around, I will definitely take a look at that. And I think as after we finish triaging these, assuming we can, I definitely want to try and get some of the asan stuff working. But Python import. No. What? So somehow we are still using the wrong version here. You might try how to, ooh, that's interesting. I will check this one out because the installing out of apt did not work at all. That's unfortunate. Apparently that page does not exist. But the exact same URL does work when I get it off Google. Okay. Sudo pip install. Oh, geez, this is there's many things to do. Yeah, sure. What's the worst that happens? I'm going to copy code randomly off the internet that somebody posted in chat and run it on my machine. Yeah, so the good part is that these VMs are pretty much disposable. The configuration is pretty generic, and while I'm not using something like Docker or Vagrant to reset them, ooh, that's an error. We got an exception. No such file or directory. Oh wow, no, this is saying I should like go offline. This is confusing and scary. Okay. That failed. Sudo pip uninstall numpy. Yes. Yes. But yeah, so the configuration of this VM is pretty straightforward. It takes maybe 10 minutes to get a new one stood up if I need to. So that's the good news. The bad news is that you know, breaking VMs is not a good thing, and it's not something that I actually want to be doing. I'd rather be doing more interesting things right now, rather than, you know, messing with libraries and things like that. But we'll get there. So yeah, it would appear that what's going on here is that it's actually compiling it for us, which is fine. That will work. So I guess while this is working, we can actually go take a look at how to do the hulking stuff. And the reason I say look into it is because it's been a little while since I've actually put one of these together. And every time I do, I have to look it up, because every time it's just a little bit different. So make sure, and I want to do a sander. Yeah, so I have a snapshot towards the beginning of this, but it's before I configured a lot of stuff. So I'm not super concerned about breaking it if I have to. So yeah, the downside of using containers is that they're very good for resetting to a specific condition that I have specified, which is a little bit difficult because as I'm moving ahead, I keep installing new things. So last stream, we installed 3 or 4 new packages, and then I broke everything. So at the very least, I would need to keep track of all of that. But while we're waiting for this to actually run, let's start working on this. So what are we doing here? We're going to use ld preload. Let's actually take notes on this. So ld preload to replace malloc. And I'm going to have to look up how to do this. But basically what we're going to do is we're just going to go over to, we're basically going to write a malloc hook to start with. And this should be relatively simple. What am I doing here? So I need to write a function which has the same primitive, the same signature as malloc. And free, I guess, would be good, but so pound include standard.io.h. We want a void star malloc, which is a size t size. And in order to get a size t, we need that work? That does not work. Docker containers let you make an image out of working container. Yeah, Docker is definitely on the list of things that I really should know how to use better and don't. Which really is my own fault. So we have this. We're going to come over here. I want to GCC. How to do this properly. So I want to compile this to a .so. So one of the many things I have to look up every time I do it is gcc-c fpic malloc-hook-o malloc.o. What? Oh, I missed a dash. And I want to do a gcc malloc.o -shared-o lib malloc.so. Okay, so if I do this, well, I didn't actually do anything here, so we're going to make this do int malloc. Okay. So oh, so I can actually just call malloc that? Okay. Pound include malloc.h void star buff is equal to malloc size printf %p buff turn buff. Right, so all this is going to do is this, assuming all of this works, is if I do ld preload is equal to malloc, or libmalloc, that's what we called it, libmalloc.so, and I do Python. Cannot open shared file. Oh, I need to give it as path, don't I? Segmentation fault? I need to save the real malloc first. I didn't think I needed to. The problem is, what's going to be a pain here, is that what I actually want to do is I actually want to back everything with mmap. Yeah. So what we're going to end up doing here is we're going to back it with mmap, and there's a decent chance this is going to fail now. But let's actually just start from there. So man mmap, because I never remember the arguments to it. So so we have our size t that. The address we want is, I'm trying to think of the best way to do this, right? So we're going to, what we want to do is in paint again, as paint. So if we have we call mmap, we get a page. We want to have each of those separated by a blank space here, so that, so let's say we call malloc of 10. We want to return, we're going to call mmap to return this thing here. And what we're actually going to return from malloc is just the little bit at the end here, which is just enough space to contain the buffer we requested. Basically what that means is that if we have an out-of-bounds write to past the end of the buffer, we're going to cause a segfault immediately, and we'll be able to use that backtrace then to know exactly what was going on. But in order to do that, there's several problems here. One is the number of unique pages we can have is very limited. I believe it is 16 bits for the entire process, so 65,000. I don't think that's going to be a problem, but it might be. What I was hoping to do was to just put a quick wrapper around malloc to tell us if that's true. It appears my code is not good enough to do that. So let's take a look at this real quick, and let's see. So, oh, okay. So using dlsim to do it is probably the right way to actually do it. That makes a lot of sense. Right, so I can deal open libc again and use that. We want to do that. Yeah, let's do that real quick. Because that way that will prove out what we're doing before we go to too much work. So do I have to actually... So does the underscore init get called automatically here? I would guess it does, but I don't actually know. So since you can't actually see the code, because I haven't talked about it, because I don't have this set up so I can show that, dl open. What we're going to do here is we're going to do we need to found include dl fcn.h. We're going to do a dl open, and I am going to just straight steal this code. So void init h is equal to dl open ld /bin /bash. Well, ld. Oh, where is? Oh, there it is. Which Python? Oh, LDD which Python? No, it's really unfortunate that both of those applications are called slightly different things. So I want lib x86 64-linux-gnu/libc.so.6. And the flags I want are rtld lazy, whatever that is. Define that? No, we did not define that. Okay, so we've imported that. We then do a malloc is equal to, or ridge malloc is equal to, yeah, we'll do it properly. Void star size t dl sim hh malloc spelled properly would be nice. So I should just be able to define both of these now. So hh is a void star, and I want a void star. Casting stuff, I'm always a little bit confused. So it's a void star ridge malloc. I think that's right. And this is where GCC yells at me and tells me I'm awful. It does, in fact, yell at me and tell me I'm awful. Where is that defined, then? Seriously? Oh. It's not that it's not defined, it's that I cannot type and... Make a type def. Ooh. That is crafty. Oh no! Multiple definitions of init? That's unfortunate. Oh, I probably want to get rid of this, don't I? Yeah, it's the RR that was killing me there, so... That's unfortunate. Check the makefile. So much in this makefile. There's not that much. It's a 60-line makefile. Here I am complaining about things. Okay, so when we make all targets. Targets is obj. We do fpic static no standard lib dash static dash no standard lib. What? Static before main. I'm getting conflicting things from two people. So the no... I think this is right. But it isn't right. Okay. Like, I expect this to work. Pass again. Oh. Duh. Why didn't I think of that? Okay. Standard io.h. Buff is equal to orig malloc size printf %p return buff. Whoa! Oh. No. That's the one I want to run, and then this. So now if I do ld preload /libmalloc python, I still select it. I don't actually know how to do this one. So I think what I have to do is I'm going to have to do ulimit-c unlimited. We're going to run this again. Python. Cool. So init didn't get called? Is that what that looks like to me? Oh. Oh, is it because you didn't use static here again? Nope, it is not. So my underscore init is not getting called. Underscore init. How does this work? I guess DL open calls malloc. Well, so given that we're not... Yeah, since printf does call malloc. Okay. Down include standard io.h void main puts YOLO/add. malloc run. Okay. malloc. Continue. We do in fact still call malloc when we call puts. Let's do this above init. If I want to do... Can I do this? No. This is unfortunate, right? So I want... I want to run strace normally, but... Wait, we have a core dump here, right? Where's our core dump? We are in underscore init, in DL open. Oh, we're in an error when we do DL open, and that calls malloc. Okay. Did I typo this? No, that's the right thing. Oh, it is in fact not quite the right thing. libc-2.24.so. Let's see if that does it. Right, so maybe it's not following the symlink properly. I don't think that's the case. Yeah. It doesn't hurt to hope, right? Isn't it having one too many asterisks? I don't think that's the problem. I think the problem is that we're calling malloc here. Like, we're overloading malloc, which isn't actually what we want to do. I think what we're going to do here Okay, I think what we're going to do here is we're going to actually use the... how do I do this? I want to do... Feels hidden calling. So what I can do here is I need to... This is kind of awful. So we're not going to hook malloc. Printf working /n. So let's verify that this works. Yes, it does work. What am I trying to do? So what I'm going to end up doing here, so I think the problem here is that we're using, it's using malloc. We've overloaded malloc. So what we're going to do instead is we're going to use include malloc.h, and we're going to have a void star malloc, new malloc size t size. So what we're trying to do here is we're going to write our own malloc hook to use mmap to set up guard pages for all the allocations. But first, we're trying to just set up some very basic wrapper to count the number of times we call malloc to know that we have the right number. I suppose we could have also done this with strace pretty simply. Or can we do it with s? Yeah, it doesn't matter. Like we could definitely do this in GDB if we wanted to. We have new malloc. This is just going to do a printf of or void star buff. Buff is equal to orig malloc size printf %p buff. Return buff. So that works. And we're going to do malloc hook is equal to new malloc. So we're going to use the built-in functionality to overload this. Oh no, malloc hook is deprecated. Really? That's really interesting that it's deprecated, given that I use that so much in CTF. And apparently it's something that's deprecated, and I assume eventually going to go away. Now, why did you segfault? You should not segfault. Core file may not match specified executable file? Oh. Well, this is getting us a little bit closer, right? In that we are getting a, we are in fact getting a buffer. So now what we want to do, like we're actually calling our stuff properly. Let's just do this the entire way. Okay, so instead of using original malloc, which means we can get rid of both of these things, overriding malloc using the LD pre... Yeah, I actually have that page open in one of my Chrome tabs. What we're going to do here, instead of calling this, we're going to call mmap. We need to pound include sys inmem.h immap null size protections. We want prot read or prot write. Our flags are map private, sure. Our FD is null, I believe? I believe those arguments are correct. Oh no! Yeah, I'm okay with all those errors. Okay, we're getting closer though, right? Right? Awesome. So we call printf instead of malloc. That calls printf instead of malloc. Printf ta-da! Except that didn't work. You can also check jemalloc as is a library to optimize. Oh, yeah, that's not a bad idea at all. So the good news here is that this works. The bad news here is that while it works, it totally fails. Because my call to mmap is completely wrong. Why is my call to mmap wrong? An example of using mmap. We're going to call null length plus offset EA offset. Following program parts prints part of a file specified in its first command line argument to standard out. That's not what I want. I just want the simple give me a page of memory with mmap. Let's see if this works. Of course, does not work. Oh. I need to map anonymous. Much better. Okay, so that totally works now, which is actually what we were hoping to see here, right? So what happened here is so the errors here that we had was that when we use printf, under certain situations, printf has to call malloc to have a buffer so that it can create the actual string it's going to print out to the screen. If you actually go back, I've actually got a stream episode entirely on using that as an exploitation vector. But in this case, it was screwing us because we were trying to call printf inside of our malloc, which was absolutely failing. What we're doing here instead is we're using ld preload to load this .so. We then The first thing we do is we call printf to force printf to be set up properly. We're then going to set up a malloc hook to our new malloc. And then this is going to basically this is forcing malloc to always use immap. And it's just going to print out the pointer and return it. Other than that, it works just the same as everything else. And of course, we're going to have problems. So because we're not actually, we can't actually free these. Let's fix that too real quick. Void star new free, void star buff. And of course, being I'm sorry, this is probably a void, isn't it? Free doesn't actually return anything. Well, we're just going to return. And we need to actually set this up. Free hook is equal to new free. Right, relatively simple. This should, assuming that we have a very small number of allocations in total, it should just work. Yeah, see, works fine. As long as we keep to a very small number of allocations. If we have too many allocations, then we're actually going to run out of space to make those allocations. For one, because we've changed the minimum allocation size from 32 bytes, I think it's 32 bytes, to, yeah, it's 20 hex bytes, so it's 32 bytes, to a full page, so 4096 bytes. Which means we're going to run out of memory much faster, especially if there's a whole bunch of little allocations being made. So we're going to use our new asanner. This is not the final version, by the way. This is just to count the number of allocations to make sure that this is even feasible. OX7. Oh. Can't open. Oh. No module named numpy. Have you still not finished? Well, it's unfortunate. I really hope this does not go through the entire same process. I'm really hoping that this works much faster this time. Okay, good. That was surprisingly painless. It also didn't crash, which is to be expected, right? It didn't crash because crashes Python, that thing. Interesting. So we're currently using the debug build of Python. What's interesting here is that that's segfaulting instead of asserting for us. So apparently using the debug build is in fact causing differences. At this point, I'm not quite sure what they are, but there are definitely differences. And we're... So where are we here? Rax plus 18 is apparently concerned that this is a null byte. Okay. And so when we run this with our version, we don't crash because we've actually made it so that that succeeds properly. Now, there's a couple things we're going to do in addition to this. First off, we want to do that button. We're going to set up guard pages first. So instead of being prot read write, we're going to do prot none. And instead of a size, we're going to do one page. This means there's always going to be a guard page there. Buff is equal to that, printf guard is equal to %p/n, or let's not do a /n. Buff and then that right there. So this will print out to us what each of our pages are. Now, let me think about this for a second, right? So what we want to do, we still need to do here, going back to our paint diagram. Right now, we're getting this right here, which is a guard page. We're getting this right here, which is our allocation. But we're returning this part right here. We're returning a pointer to the start of it, as opposed to a pointer to the end of it. So what we want to do, as long as size is less than 4096, we should be good. We should be able to come in here. And looking at these sizes, it looks like they're all less than 4096, and so we shouldn't be concerned. What I'm a little bit concerned here, though, is that, I'm a little bit concerned that it's really only calling malloc 3 times. It's calling it calls every time it calls malloc is prior to our code running, is a little bit concerning to me. Given that we definitely look like we have a heap overflow. So we want size, instead of returning buff, we're going to do buff plus one page minus size. So what that's going to do is it's going to return something, it's going to return a pointer that is just prior to, I did actually compile, right? One thing I don't like about having all these warnings, like if we were writing code for real here, we would clean up all these warnings and make them go away. But because we're awful, awful people who are doing things like trying to break software, on my machine it calls malloc. Yeah. What I'm thinking here is using the debug build is biting us in the ass here. Not sure why. It's interesting, but I'm not sure why. So I think we definitely need to switch to not using the debug build. So back to the original problem we were trying to solve. By original problem, I mean what we started with here was usr bin python star is that our Python is currently the Python 2.7 debug, because that's the one I have in the system that actually made it work. So apt-get reinstall Python 2.7. No, I don't want reinstall, I want install -- reinstall. Does this replace it? It's going to be really unfortunate if the problem was I was trying to install Python and not Python 2.7. I'll be kind of sad if that's the case. Because like we spent like 20 minutes on that at the beginning of the stream. Nope, it's still the same thing. Apt-get reinstall Python. Okay. Sudo dpackage -p Python 2.7. So supposedly this should just work. Sudo aptitude reinstall python 2.7. apt get install -- reinstall python 2.7. Why is this not replacing the binary? apt-get install reinstall python. Come on, Google. No, that's not my problem. apt-get Let's try this one. Nope. Okay, so we could not. Where does it tell me? We have Python, Python all. All of these things, it says, depend on Python 2.7. Nope, that one didn't do it either. What's the okay. B package -s /usr bin Python minimal. Reinstall Python -minimal. I think this is what we wanted to do. No, it is apparently not. Okay. Python 2.7 dash. Ooh, that's good. That looks good. That does look good. I think that finally worked. Did finally work. Okay. Oh my god, I hate you so very, very much right now. I hope you know that. Okay. Uh, this time, we're going to be a little bit smarter. We're going to use virtual env. We're going to do a pip install numpy. Sudo pip install numpy. Pip sudo pip remove numpy. Uninstall? Was it the right mnemonic? Yes, go away. Remove all of that. Okay. Hopefully this works now. Even if I use virtual env? Oh, man. Well, the good news is that I should be able to then do... If I'm in a virtual env, don't use sudo. Well, this hopefully works. Okay. Interesting. So I believe we're back to the point where we started. But we no longer have a crash. Right? This appears to run without a problem. And exit. Yeah, there's a lot of like environment stuff that I don't know how to use and really should. So you just fire up work on numpy or make virtual env. Interesting. Yeah, especially virtual env. It's something that I mean to learn more about and never have. I'm not quite sure what to do right now. In that we got kind of what we wanted set up for today, but now our crash is no longer reproducing. And I'm not sure how to feel about that. So let's try some of these other crashes, right? That one works basically the same way. Okay, so I mean, like, some of these are still seg faulting. But the one that we're actually looking at so how hard is pyenv to use? Like, I would think it's relatively simple. But I'm not sure. Hmm. I tried apt-get purge, which Python, then doing a reinstall. Well, so I'm definitely not using the old Python. Like I've now successfully reinstalled Python. That worked fine. It would appear, though, that there is in fact a version difference. I mean, there's a number of different possibilities here. One of which is that we just reinstalled Python or numpy, and we reinstalled numpy. So we just reinstalled numpy 1.12.1. So this should have been the same version that we got last week. I'm not sure. Or not last week, last stream, so Monday. I'm not sure why we're not getting this crash anymore, though. Like, we definitely had this crashing on Monday. And we were crashing in such a way that it looked very probably... like, it looked like we definitely had a situation where we were getting an out-of-bounds write affecting the metadata on the next allocation. Which is definitely what this looks. Well, this might be made me feel pretty dumb. No, okay. But still totally doing that. So the original version of it, like we've modified this script. No, I want to be over here, right? This is the original version? This was totally causing a crash yesterday, Monday. It's no longer causing a crash, which is unfortunate. But at least at this point, let's move on. Because at this point, we've now spent about 4 hours on a single crash, and I'd rather make progress on different things rather than running around in circles trying to figure out why this one isn't reproducing. Like this one. However, is this one of the... So one of the issues is that many of our... Oh, look at this! I suspect this one will, in fact, is related to the same bug. My guess here is that a lot of these crashes are all basically the same thing, which is that the get field and set field functions don't bounds check at all. OX7F 689B75. So if we do Python, this thing, that thing, I have a core file, and --args, bang, Python, run it. What's happening? So we get a sigsegv, copy swap? That's interesting. What's going on here? This is actually a new crash. So for anybody who didn't follow all those jumps there, we've decided that the crash we were looking at on Monday is not reproducing, and rather than trying to figure out why it's not reproducing, we're just going to move on. And this is the next crash now. We are trying to read from a pointer that appears not to be valid. And this is what's happening. So we called trap z with a set, an empty set. We then called get field on trap z. with arguments of common type, whatever that returns, and an int c of this as a float 32. Okay, and what happened? We walk through here. We have a fast function, call function, something in multi-array. We then have a pi array scalar, and we're going to do a copy swap, whatever that is. And the actual exception we're running into is we're trying to read out of RSI, and RSI is not a valid address. Okay. So we're at 5554, which is actually well below anything useful. NMP tuple. Yes, it's a tuple, not a set. Sorry. Calling things the right things is something I do poorly at sometimes. Yes, we're calling trap z of a tuple an empty tuple, not a empty set. Interesting. So, for whatever reason here, what is going on here? How did we get here? Okay, before we take too many looks at this, we have a second one we can look at too, which is supposedly the same RIP. So we're also calling getField in this one. This time we're calling getField on a negative number, which I believe is 2 to the 32. We're then the arguments to that are a float 16 with no argument, and an int c of a log at exponentiate short u. Okay, that is looks like it's not necessarily something particularly useful. It looks like it's probably going to be basically the exact same thing, right? Dash dash args, bang bang. So we crashed in the same spot. And the same thing, we've got an RSI of a weird address. Like that address is really odd. RIP -5. So we did a test RSI, a jump if it was 0, and then we tried to use it. So whatever half copy swap is, it basically takes 2 arguments. The second argument we then tried to read stuff out of. It's supposed to be a pointer, and it's very clearly not a pointer. If we look at our backtrace here, so we have the source, which we're trying to copy out of. Makes sense. We say that's a scalar. So some point in pi array return, we're going to create this. So luckily, we have the source code here. So numpy. So this is in numpy core source multi-array. Actually, before we do all this, is this? Yeah. We're going to do ctags-r dot. Password type. So what we're doing here is we're going to set up ctags properly. Well, properly is a loose term here. We're going to set up ctags for numpy. And we're going to actually take a look at this source code. We have the source code available for us for numpy. So let's take advantage of it and see what exactly is going on here. And so what ctags does here is it's going to let us basically jump around a little bit, and it's generally going to be a lot easier for us to read things. So core source multi-array scalar. No, we don't want to start with scalar API. Yes, we want to start with scalar API. In particular, we're going to be at line 863. So that was called, so this calls pi to scalar. We had pi array return. It's going to call this and the data. So this is called with 3 arguments as opposed to the 2 arguments that this is. So there's a macro here which define pi to scalar. Data is still the first argument though. So we know that whatever the... Interesting. So we know that pi array data of MP is an valid pointer, however that happened. MP is the argument to pi array return. So what is a pi array data? A pi array data is going to return a pointer at that thing. Okay. Oh no, oh no. How do I... There we go. Go up. We're going to do x/20 gx. Okay. Well, that doesn't look right at all. That looks much better. But it still doesn't look right, right? So we're still totally seeing that that pointer is there in this MP object, whatever an MP object is. So that doesn't tell us that much. It just tells us that we somehow got an MP object that is clearly wrong. How did we get there? Let's think about the right way to approach this. We currently have a crash in a read of memory that is unpaged. So we're probably looking at a negative offset for whatever reason. Let's start by actually going and looking up what this thing is supposed to do. What's the best way to do this? Control Shift N, numpy, and the function we're calling is a get field. Numpy get field. Thanks. But here, let's I'm going to make this so that we can actually that should work reasonably. Why aren't you showing up? Apparently, OBS will not give me Chrome right now. That's unfortunate. But, and again, also being unfortunate is the fact that the documentation for get field doesn't tell me much at all. So the first argument of get field, if it's an ND array, is the type. The second is the offset. So what I suspect we can see here, so if we new import numpy as np, you should see r is equal to np.nd array. Then we're going to do a array.get field 1 4 Oh, let me save this. Has no. Oh. Helps I can type, right? Shape not found. So what did we call this with? Oh. Buff1. We called it with a negative. The first argument, no. The first argument is a empty float. Float to 16, like that. Oh, we're crashing before that. We're going to do a np.negative 2 to the 32. So this is basically what we were doing before. And we still get a segfault. That's good. Well, it's good for us. It's not necessarily good for numpy. It's kind of hopeful that what we were going to end up with here then was, since we're looking at the second argument is an offset in bytes. And I think I subtracted the wrong direction. I went the wrong direction, didn't I? Because that looks much better. That the pointer, that the essentially what's happening here is get field and set field just straight up do not take, like they don't check the bounds on whatever the thing is, the offset. So I believe there's also a set field, which I believe is the second largest group of crashes we have, which is going to set a value to be placed in a field, a type, and an offset. So if we come in here, we're going to change this from get field to set field. We're going to put a 42424242. And set fields in a non-void array scalar. Okay. Okay. So in this crash, whoa, what is going on here? 7FBDF. Yeah. So in this one, we call set field on a full like. -1, and the other argument is a np.complex 128. 128. Can't open crash. Oh, crap. Where were we? ff689b7e5 python crash.py. That is indeed a segmentation fault. So we don't see quite what I was hoping to see. So RDI, we are writing AX to RDI, and AX is null byte, right? No, it's 2 bytes. AL and AH are 1 bytes. So it's trying to write whatever 7C00 is, because we said it was a float 16. Okay. Not sure what relation that has to the OX41414 or the 42424242 we passed in, but okay. Can I have a float 64? What happens if I do this with a float 64? So I'm not sure what these values we're writing are. Because they're not what I want to be writing. They're some random value. Well, it's not random. It's related to the data we're trying to write. But like if I change this to that, what happens? It looks the same, doesn't it? No, it changed. It was 41D09, 0909, 0909, 0904. Whereas this was 09090908. So somehow that converts to the 42424241. However, that works. So I can get the seg fault. Yeah. I highly suspect that all this is that the get field and set field functions do not validate the offset argument. That they just let you pass in whatever value you want for that, and they're just going to work. Because why would you ever pass in an invalid offset? Which I believe is very similar. So the original crash we were looking at was, let's see if I can, I've got it saved in another video, don't I? So the earlier videos, I posted it in almost all of them. So this is the original article that started all of this, was trying to find some of these. So what's interesting is that the documentation for it, and I'm sorry that my computer's being dumb and won't let me show you this, says that, at least on get field, that it is validating the second argument. So it will validate this argument to make sure that this is smaller than the size of this. But it's not going to evaluate the offset argument, which is going to tell you how many bytes to skip, because who would ever try and give you too many bytes? Okay, so this is actually distinctly different from the crash in the article, or the exploit in the article, which was using the resize to get a resized allocation. Whereas we're just straight up using get field and set field, and it's perfectly fine with that. So the question is, how do get field and set field work? So we clearly control the values that are being written here, because it definitely changes when I change what's in it. But how do those actually change? So let's switch over to, oh, nope. We're gonna come over here and do, instead of 4 2s, we're gonna just do a 1. Fun fact, array get field Interesting. So they actually removed a check at some point to allow for this. That's interesting. So according to Jafra, it looks like we this has been introduced here. That they removed a check at some point, and now we're apparently perfectly fine with crashing inputs. We are causing a segmentation fault. Oh, we're totally converting this to a float, aren't we? So if I do, how do I do this? Import struct. So this is struct.pack Python struct. I want a float f. So I want to unpack. Actually, I'm going to be a terrible person and from pwn import star. And I want to do u64 struct.pack as a float the number ox41414141. This, ow, okay. Struct.unpack, I want a unsigned long. Unpack requires a string of length 4. Oh, is this only giving me a int? Okay, so I want a regular long, an unsigned long. What? Print fl is equal to struct.pack f 2, 3, 4. Oh, that's. I always forget to do this properly. Print repr fl. What is FL? FL is a single byte? Oh, that's not right. FL is now 4 bytes. So I want to use a I here. Assignment to 0-D array. Print repr right. Oh, now I'm doing it wrong. Okay. We're so close. We're so close, aren't we? Oh, I should be doing this as a double, shouldn't I? Because this is a double, lowercase d? Lowercase d. And this is definitely now a q. Unpack requires a string of length 8. 1, 2, 3, 4, 5, 6, 7, 8, 9? How's that giving me 9 bytes? I'm gonna double 9 bytes. That's 8 bytes. Oh. Because I'm being dumb here, and that's close. We now have a 41414141 we're writing. It's not quite set exactly the way we want it to be set, though. 41, 42, 43, 44, 45, 46, 47, 48. What is this? Oh, that's awesome. Because of the slowdowns caused, we've removed them. Oh man, I love that as a git commit message. We removed the safety checks because they were slow. So currently what we have here is we're actually able to write... oh, we're writing a double. That makes sense. Let's see. Go this way. What if we do a float 8? That's a thing, right? Is it a thing? Oh, it's not a thing. So, unfortunately, what we're seeing here, which I guess isn't that big of a deal, but it's a little bit unfortunate. We do a 64. So this we get to control 1, 2, 3, 4, 5 bytes. This game is a completely different crash. Where are we crashing? We're trying to write from XMM0 is print So that's kind of a pain in the ass in Python. There's assert, which can be disabled, but no one disables those. The -o Python flag does this affair. So at this point, I believe we have a arbitrary write to any location we want. Because $RDI minus, or x/x $RDI minus OX41414141 is in fact valid memory. If we do a print so print hex ID of R. Oh, that's interesting. What I was expecting to see here was that R would be that object, but it's not actually that object. I'm not sure what that object is now. So ID, in terms of exploitation, ID returns you the pointer of the thing you pass in. Which is absolutely amazing if you were trying to land a memory encryption bug in Python. But it's not returning the value that we're writing to, which is odd. That is very suspicious. What is that returning? Where is that? So this is the pointer. This is what... This is what this object looks like. Oh, we look at that. And then if we do x/x of RDI minus OX41414141, that is the... Okay, so... Yeah, so it's not the direct object. Yeah. Yep, that's exactly what we're seeing. Which is a little unfortunate. If we could get the... So the object under the hood is malloc. I assume it's malloc. But ID isn't giving us that pointer. ID is giving us the pointer of the wrapper around that object. Because if I can get this address, then I can get an arbitrary write of anything I want. And I can write 5 bytes to it that I care about, and some number of bytes that I don't. Which isn't ideal, but I'll take it. Like I'd much rather have that than something that doesn't work. Actually, let's see this for a second. FL is equal to A, B, C, D, E, F, G. That's 1, 2, no, H. That isn't even close to what I wanted it to be. So if we can get a good leak of the pointers from malloc, for obj in globals, print hex, print obj, comma, ID obj. Hex ID obj. So that way I can actually read it. Oh, these are strings, aren't they? Dictionary change size during iteration. Did you need the float 64? I don't think it actually uses the float. I think it's using it for a size only, at least according to the documentation. It's just using it for a size. Yeah. At least I think that's what's happening. I don't know for sure, but that's definitely what the documentation suggests. That it takes that as a size indicator for what it's going to write. And then we're just writing to the 0th offset of it. Because, you know, why wouldn't you do it that way? How do I do this? I want to do Python print. Globals is a dictionary, so I actually want the keys of it. So for obj in globals dot values print for kv in globals print k comma hex id v. What? Oh. Keys. Let's just do it this way. V is equal to... Sure, that should work. Ooh, package will give me a pointer into those objects, which I can live with. But since you were packing it as a double. No, I don't think it has anything to do with packing it as a double. I think it has to do with numpy needing to know what the size of the elements are. So what I'm thinking here is we can use that doc string, or we can actually just allocate our own variable. So use that to get a pointer into our, where's FL? So FL is in one of the arenas, whereas RWI is ending up in a different arena for some reason, which is odd. So RWI is a integer, whereas the FL is a string that ends up in a different arena. Okay, I guess integers get stored directly as a pointer to the thing on the heap, whereas a string is a wrapper around a thing. Okay, I'll buy that that's a thing. So where are we? So we have this. We have a way to get a pointer to the heap, and we have an arbitrary 5-byte write we get, plus some junk bytes. So we can absolutely turn that into a into code execution. Unfortunately, we've been going for about 2 hours now, and I think this is probably about the point to call it a day. We're at the point where we can do an arbitrary read and write, and the next step is going to turn this into a actual exploit. So we're going to have to basically, what I'm hoping to do here is next Monday, we're going to take the get field and set field functions, and we're just going to define a set of wrappers around them to let us read and write arbitrary memory. And then we'll take those primitives and turn them into a arbitrary read and or into just code execution without using anything, dangerous. We're just using numpy, right, guys? We're just using numpy arrays. How could that possibly be dangerous? We're going to turn that into an exploit. I think it's about everything. At least that's everything for this week. So let's see. Is there anything important? So if you have any questions or comments or anything like that, the easiest way to get a hold of me is Twitter, but leaving a comment on this video is also going to get to me relatively quickly. And if you're not already doing so, I'd appreciate it if you would follow me on Twitter. I'm occasionally late to these streams like I was today. I was about 15 minutes late because of bad traffic getting home. And the easiest way I have to let people know about that is via Twitter. I can very easily go, tap, 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 I'm going to be late tonight, but I'll still be there. So the place where I usually make those types of announcements, as well as talk about what the next stream is going to be, is usually on Twitter. So if you're not following me and you're interested in knowing things like what we're planning on doing for the next stream and things like that, Twitter is the place to do it. So disconnected, my day job is just development stuff. As you can tell, it's not as a, the code I'm writing is very different than the code I'm writing here. It's much easier for people to read. Yeah, my day job is working as a developer, so yeah, I think it's about everything. Like I said, if anybody has questions or comments, Twitter's the easiest way to get a hold of me if it's something immediate, but comments on the video also work perfectly fine. So thanks everybody for showing up, and I will see everybody on Monday. Bye, everybody.